Sometimes instead of one variable being a constant multiplied by another variable, our first variable is a constant divided by another variable. And in such situations, we say our first variable varies inversely as the second, or is inversely proportional. The key word to look for here is inversely. Whenever you have inversely varies inversely or inversely proportional, we would say our first variable is our constant of proportionality divided by the second variable. So watch out for that. When it's directly proportional, its one variable is k times the second variable. When it's inversely, it's the first variable is k divided by the second variable. So with that in mind, let's read our next problem. Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas is inversely proportional to the volume of the gas. So without reading the rest of the problem, I already know my basic equation. I'm going to use P for pressure and V for volume. And since it said pressure is inversely proportional to volume, we can say P equals K divided by V. Now let's read the next part. It says, suppose the pressure of a sample of air that occupies 0.106 meters cubed at 25 degrees Celsius is 50 kPa. kPa is an abbreviation for kilopascals. It's not going to have anything to do with the calculations of our equation. Now it says find the constant of proportionality and write the equation that expresses the inverse proportionality. So the pressure that we're given is 50. We'll put that in for P. We don't know what K is. That's what we're trying to find. The volume that we're given is 0.106. So we have 50 equals K divided by 0.106. And now to get the K by itself, we multiply both sides of our equation by 0.106. So 0.106 times 50, we have 5.3 equals K. So now that we know what K is, instead of P equals K over V, we can write P equals 5.3 over V. So now to answer part B, it says if the sample expands to a volume of 0.3 meters cubed, find the new pressure. We can put 0.3 into our equation for V. 5.3 divided by 3, if we round it off to, say, 2 decimal places, that's a 0.3, not 3. We get about 17.67. Okay. And the units for pressure that we're given are the kPa. If you would like to solve the next problem on your own, pause the video now and resume when you're ready to see the solution. Here it says the weight of an object varies inversely as the square of its distance from the center of the earth. So there's a couple of things about this one. First, we know it's a varies inversely problem, which means it's going to be K divided by instead of K times. I'll use W for weight and D for distance, but it doesn't say weight varies inversely as distance. It says weight varies inversely as the square of its distance. So our basic formula would be W equals K divided by D squared. And here it's distance from the center of the earth. So if we have a planet here, we're measuring distance not from the surface of the earth, but from the center of the earth. So our next sentence that we're going to use to help us figure out K says, an astronaut weighs 180 pounds at sea level, which is about 4,000 miles from Earth's center. So we have 4,000 miles there. That's our distance from the center in this case. So we have 180 for the weight equals K divided by, and then for distance we have 4,000 squared. If we go ahead and square that 4,000, we have 180 equals K divided by 16 million. Make sure you include all the zeros that you need there. To get K by itself, we multiply both sides by 16 million. We're going to have big numbers in this problem, but especially since we've got calculators, big numbers really shouldn't intimidate us at all. So now we multiply 16 million times 100. Oh, I typed something wrong in my calculator. I have to start over. 16 million times 180. There we go. And I get 288,000,000 equals K. So now I can go back and write my basic equation as W equals 288,000,000 divided by d squared. Now let's look at the last part of the problem, which says, how much does the astronaut weigh 2,000 miles above Earth's surface? The mistake that a lot of students make here is plugging in 2,000 for d. But d, remember, is the distance from the center of the Earth. So if the astronaut is 2,000 miles above Earth's surface, and the distance from the center to the surface is about 4,000 miles, put together, that overall distance would say that the astronaut is about 6,000 miles from the center of the Earth. So here we're going to plug in 6,000 for d. And we have W equals 2,880,000,000 divided by 6,000 squared. So if we take that 2,880,000,000 and divide it by 6,000 squared, here we get 80 for our answer. We're finding a weight, and the units for weight on this problem are pounds. So our answer is 80 pounds.